Okay, I think we'll make a start. Hi everyone, welcome to today's webinar. This is part of a series of presentations delivered by educators under our Teaching Innovation Awards initiative. For those of you who are new to LearnSci, we specialize in education technology designed to support students' technical, analytical, and experimental skills within university science programs. I'm Bill Heslop, the Managing Director at LearnSci, and for the past 6 years, we've been running the awards to showcase best practice in digital innovation within universities. The projects involved cover both work done using our own resources, using with our academic partners, and also non-partners who have other forms of digital innovation that they want to share. The award aims to celebrate educators and teams going above and beyond in teaching practices, and we've definitely got an example of that today to look forward to hearing. They also foster community collaboration by sharing innovative ideas to address current sector challenges and inspire fellow academics. So if you're interested in participating in the awards and finding out more, if you go to our website, you can find summaries of all of the projects involved over the past 6 years and information about how you might go about applying for this year's awards, which kick off later this autumn. And if you're also interested in education research and thinking about taking projects through to publication, then there are pages on the website with information about how we can support you in this area. So for today's webinar, a few details regarding logistics. The presentation is being recorded and will be made available publicly afterwards for people who couldn't attend on the day. So please mute your microphone during the presentation. If you're happy to keep your cameras live, that's great, but feel free to turn them off if you prefer. There'll be a question and answer session at the end, so either please post your questions in the chat and we'll read them out, or ask them directly through the microphone and engage with the speaker and the rest of the participants. So without further ado, it's a great pleasure to hand over to Joyce Sewry, Senior Lecturer at Rhodes University in South Africa. Over to you, Joyce.
Thanks, Bill. Thanks for the introduction, and thank you to everybody who is attending. First of all, I'd like to say thank you very much to LearnSci for the award and for all the background support in all that we've been doing so far. With this award, I want to thank you also then that gave me the opportunity of attending the conference at Royal Holloway, which was phenomenal from a conference point of view and from the campus point of view. It was just beautiful altogether. So I'm situated at Rhodes University, and there we go. And you can see in South Africa, at the bottom end of Africa, this is a pretty picture of our main street, called High Street, just very British, very settler, with a cathedral in the background. And this is where Rhodes University is located, as a very small university by South African standards. We have 9,000 students. And the chemistry department is one of the very active research departments of the university. We know that it's known across the world that the students do lack the requisite numerical skills to tackle our first year chemistry at Rhodes University. It's a real problem numerically. Of course, I'm not going to go into what's going to happen with AI now as well. We all know those challenges. It started, of course, with the fact that because they're using calculators, they don't get a feel for numbers. And therefore, not only do they not have algebraic skills, they also don't understand numbers very well. And so we have made use of LearnSci scientific numeracy smart worksheets to try to identify these gaps at Rhodes University. Later, I'll speak about further work as well. The aim of using it, this study was done in 2024. The aim of using this was twofold. To find out, first of all, where the gaps are. Is it true what we think the gaps are? And once we've actually identified the gaps with a proper study, could we support the gaps and improve the numeracy proficiency of our first year chemistry students. So they're scientifically numeracy smart worksheets, but with a chemistry background so that we can use them in the chemistry field. But most science students should be able to do the numeracy tasks available. How did we do this? Well, we did it with our first year students in the first 3 weeks when our first year students arrived on campus. The smart worksheets were open to them. I was teaching them at the beginning. For the first 2 weeks, I teach them numeracy skills. I teach them an introduction to chemistry, a little bit of stoichiometry, a little bit of gases, and all the numeracy that goes with it. So while I'm teaching it, the smart sheets were open for 3 weeks, and they were allowed to have a maximum of 3 attempts. It was compulsory for all our first year students to do it because it counted towards their semester mark. However, for the study, which I will be giving the details of, we only used the students who consented, of course. We only used their results for that. We couldn't go according otherwise because of ethical. I'm sure you all know about that. But anyway, so we still had a large cohort, which fortunately did consent, which was great. The Smart Worksheets do randomized questions, so no student will get the same set of questions, and different students, even if you repeat, you're going to get different questions. There's a huge bank, they get randomized. You do not have, lecturers do not have to worry about questions, students repeating questions at all. Of course, there's immediate feedback. Is it right? Is it wrong? You've done well, you haven't. If you have got it wrong, there is an auto-solve button, which is really, really great. And the students can use it then to get some feedback onto how to attempt the question next time. As I've said, there are 3 maximum attempts for this study. We did analytics of performance, and a great job. Thank you very much to the LearnSci team who did the analytics of the performance and who analyzed the questionnaire for qualitative feedback, which we did as well. So it was a full study, both quantitative and qualitative, with our first year students of 2024. The first year chemistry students, I think, are like many, many universities. Chemistry is a prerequisite for a number of departments. At Rhodes, we do not have medical and we do not have engineering. So chemistry is a prerequisite for all the life sciences. So the zoologies, the botanies, all of these students had to do chemistry 1. So they were all included in this. The topics that were covered are divided into 6 topics, the displaying numbers, and under this you can see what we covered in each of those. Ratio and percentage. It has been known over many, many years that ratios and proportions are a definite stumbling block for chemistry students, and that they are so very important in chemistry. It's not only for chemical equations and dilutions, it's for thermodynamics, it's for quantities. Ratio and proportion is very important, and students have over the years found it very difficult. Scientific units, our usual scientific units of and conversions of milliliters to liters, cubic decimeters, moles per cubic decimeter. That is what we're looking at in scientific units. And then something on data. Most students have to do, of course, have already at school as well, to see in the spread of data, means, modes, averages, etc. Rearranging and solving equations. Well, I think that is quite obvious. The one that also goes with that is the pH equations, which are not quite as straightforward as other linear equations. And then graphs. And graphs are the usual, again, finding best fit, identifying outliers, and also deciding the axes, that you don't have to have an axis from 0 to your maximum. You can start an axis somewhere else as well to get maximum information from the graphs. This is an example of what it would look like, what the questions would look like. This is an example where students had to actually fill in a correct answer. Some of the questions are multiple choice, but this is one where they actually had to do a computation on a calculator next to them and enter the correct one. It was also important that they looked at the number of significant figures when they were entering this. And as you can see, the instructions say give your answer to 3 significant figures and in scientific notation. So the instructions are very clear for this worksheet. And the results were quite interesting. As you can see, we had 210 who consented and whose results we used. This was out of a class of about 350, so a very high proportion of our class consented to the results being used for the study, which was great. The top scores were for displaying numbers and equations, and I would assume that that would be because they get lots and lots and lots of practice at school. So these are all first-year students. They've come straight out of their school leaving exams. They would all have had to get at least 50, but hopefully 60% for their school leaving exams for mathematics. And yeah, so their mean score was 85, 86 basically for displaying numbers, and 84 for rearranging and solving equations, which is good, which is great, and I don't think unexpected at all. The other one was that you can see that ratio and percentages was actually quite high. I was surprised at how high it was, that it wasn't lower, but I have a feeling that it's because I had already started teaching the students about ways of doing proportions. I have a set way. It's quite procedural, I must admit. It's not using units. It's a procedural matter of using proportions to solve different problems, and hopefully maybe some of that they'd learned from that it was not of the lowest. So I was pleasantly surprised that ratio and percentage wasn't one of the lowest. The lowest one was by far graphs. Graphs was very low. This meant that the students they struggled with finding outliers, identifying outliers, finding best fit. And another real problem was that they struggled with the axes, trying to get a good axis and not, as I said earlier, having to start at 0 and going to a maximum. You can, to get your graph better, start at a different point. And then you can see the second lowest also was the data. Data is a problem. Our children come from the schools with problems with data, and it is known in the schools that many of the teachers actually ignore the data part of the syllabus, which is very, very sad. The other interesting thing was then the results also show the auto-solve attempts on the questions. This was interesting in that you can see that scientific units had the largest number of auto-solved. And this is great because scientific units, they did not do very well. As we saw, they didn't do the worst in it, but they did not do very well. But it means that they saw that they needed help and they were prepared to search for the help. We were disappointed that the auto-solve on the graphs was so low, but we suspect that graphs is the last section, the last topic on the Smart Worksheet. Smart Worksheet is actually quite long, and that by the time maybe they got to graphs, they were tired and they did not go to auto-solve to assist them. They were told that they did not have to do the worksheet all in one go, so they could stop and start. So tired might be a factor. If they were trying to do it all in one go, they didn't have to, but maybe some students, and I assume actually many, might just have sat down and tried to do it when they had a free afternoon, when they weren't in practicals or something like that. And therefore, it's my suspicion that the auto-solve for the most difficult one, for graphs, was not as good. And we also did analytics on the first and second attempts. As I said, they were allowed to do 3 attempts maximum, but only 6 people did a third attempt. And you can see from this slide that 41 did 2 attempts. And so we looked at what happened with theirs. You can see there's a good increase in the mean score from 76 for their first attempt for those who did both these. The first attempt is just for those who did first and second attempts. So they went up from 70.6% mean score to 82, which is really, really a huge improvement and a significant difference statistically. Most of them completed. We saw the high completion rate on the last slide. So significant, not significant there. But auto-solve, they definitely did less auto-solve, which one can deduce then maybe that on the second attempt, they knew more. They might have done auto-solves on the first one, which might have helped them understand, or during the second attempt, they might have understood more. But it is great to see that they needed the auto-solve less. Of course, that goes also with the fact that the mean score was higher. Then we did the qualitative survey, asking them a number of questions. I'm only going to deal with 2 of the questions here. And the first one was what their perception of the helpfulness was for each of the topics. I see the end didn't come out. It's 196 responded here, which is an incredible percentage, 196 of them. So we can see that they find scientific units the most helpful, which is great to see, because we could see that scientific units were one of the ones that they did really badly on, and 75% of them said that it was very, very helpful. So, and if you look at 95 said it was helpful and fairly helpful. So they found the one topic that they struggled with, scientific units, where they used the auto-solve as well. And I'm sure the auto-solve contributes to the helpfulness as well, that they did really, that they found that very helpful. Also, displaying of numbers was helpful, and graphs, which they did poorly on, not so helpful. I'm not quite sure why. I would have hoped that they would have, but again, maybe towards the end, they just went through it more quickly. On a scale of 1 to 10, they were asked how they would recommend the scientific numeracy resource to other students. And you can see that they really thought that it would be a good thing to recommend, which is great to see. They obviously found it useful, and they would recommend it to other students to assist them. Some of the student comments, only 39 gave us free response comments, spoke about the helpfulness or enjoyment of it. They spoke about identifying areas of unfamiliarity, strengths and weaknesses. They said that they realized that where they needed to give more attention. They also found it useful, and you can see their refresher from previous learning. They found it useful to revise what they had done when leaving school. A good idea of just to get them back into the swing of things, of their numeracy, things that they'd learned at school they might have forgotten over a 3-month holiday, or just a good refresher from it. It was challenging in a positive way, which is great. It's a bit difficult, but it keeps one thinking. And those are really good and useful ways of seeing it. Nothing really bad, Kay. I mean, there was no one who said, oh, this was awful. The one said the quiz is too long, it took a long time. Yeah, 4 of them said that. It is long, but also in the first week when it was available, they didn't have pracs in the afternoon, so they would have had more time then as well. They did have 3 weeks into which to do it. And we have discussed this since then, but we cannot see an obvious way of delinking certain topics and dividing the worksheet into maybe one or two. The worksheet is good as a total. In the second phase, we've done a little bit more work now, and Rhodes University is now collaborating with the University of the Western Cape, again, with lots and lots of support from Learnsci, especially Anne and Emily, and I want to thank you now for that, and I'll thank you again. And you can see here where we are located now in South Africa. University of the Western Cape, on the Western Seaboard, right in Cape Town. Most people know where Cape Town is. Most people know that it's a large city of South Africa, where Parliament is located. It's a city environment, a city campus, and we have our dear Rhodes University, which is a rural campus in a small little town in the Eastern Cape. So we were there then going to look at what are the differences or not between these universities. So in 2025, University of Western Cape and Rhodes University collaborated, and we did the similar study with all our first year students again. University of Western Cape's Chem 1 students, Rhodes University's Chem 1 students. A rural university versus an urban university. Both of our universities draw students from all over South Africa, but Western Cape, of course, draws mainly from the Western Cape, and Rhodes University mainly from rural Eastern Cape. Was interesting when we've looked at that Western Cape, also both Western Cape and Eastern Cape draw quite a lot of students from KwaZulu-Natal, which was interesting. Also, the other thing is at Rhodes University, most of our students are in residence or on campus. We're a small little town. Universities within easy reach. They can easily get to electronic devices, into our computer labs. Not as easy for Western Cape. Many of their students live off campus, commute a long way. And that was something interesting I did take out of the conference now at Holloway, was the emphasis that British universities are looking at commuting students and how to support them. That came through quite strongly, and I thought that was interesting for the UWC context as well. And so when we did this, we were trying to compare, and we were wanting to ask whether the differences or the similarities, are they cohort related, are they university related, and whether, or is it systemic? Is it from, because we get these students from South Africa, from the school leaving system, is it from the school leaving system that we are inheriting these problems? And so just to give you a few preliminary results, the table here shows you the scores for UWC and the scores for Rhodes, as well as the auto-solve for them. You can see our large numbers here. Again, only students who consented, and we were very privileged to get our students to consent in the numbers that they did. Interesting, the top two scores were the same for, it was the same top two for both UWC and for Rhodes. You can see a slight difference in the average score for UWC, Rhodes being slightly higher, and equations also Rhodes being slightly higher. Not a huge amount, they are slightly higher. I think we did look at it, they are statistically significant, but you can see they're still in the same ballpark. And then for the lower ones, there is a little bit of a distinction. The lowest, this data, comes through lowest for both of ours. Very little difference, 69.6 and 69.9. So our scores are very similar there. Data definitely being a problem. I have worked quite a bit in schools and with teachers, and it does not surprise me, as I said earlier. Data only came into the curriculum probably into the school curriculum about 10 years ago. It does get introduced already in grade 9. So our schooling goes from grade 9 to grade 12, does get introduced already in grade 9. But many of the teachers are old teachers who weren't trained in data, and they kind of try and avoid it as much as possible. The scientific units was second poorest for UWC, whereas for Rhodes, our graphs are still bad. You can see UWC did a little bit better in graphs than Rhodes did, and we did better in scientific units. Again, by the time they did this, they might have been at my lectures on scientific units already. I'm hoping that maybe they've taken something from my lectures already, I'm not sure. So there is that little bit of difference. The systemic averages is definitely systemic. As far as AutoSolve goes, scientific units, UWC, high, which corresponds to the Rhodes only study the year before, interestingly enough. And this time, at least, the Rhodes students used AutoSolve for the graphs, which was good to see. And with that, I'd just like to thank everybody who has been involved in these studies. All the students, of course, the LearnSci team, the UWC team has come in on the second study with Honji and Candace, and then the fellow authors of the paper that has already been published, Mike Davies-Coleman, who's been both at Rhodes and at UWC, and that's the link between the two universities, Emily and Leanne, and all the others from LearnSci. Thank you very much. Thank you for all your support. It's an ongoing journey, so I can't say it's been a pleasure. It is a pleasure working with you. Thank you so much.
Brilliant, fantastic. Thank you, Joyce. If there are any questions from the audience about anything, either the design of the study, but also sort of the impact of the analysis and understanding of the impact on sort of quantitative skills development. Leanne.
Thank you, Joyce. That was great. It was really lovely to see the additional element with with the partnership with the university. I was just, whilst others are maybe thinking about their questions, I was just wondering if you could touch on, because it's always something that I find really fascinating, if you would maybe touch on the differences in the cohorts and the difference in languages between the two institutions and the types of barriers, perhaps the challenges that you have more so than some of the UK institutions, of the number of languages that students are coming into, and then maybe how that impacts on things like terminologies, understanding how questions are written and so on. Because I think that's something that as educators we have to be really mindful of when we're just producing resources that we think are going to help everybody, when actually we need to be really mindful of how these things are interpreted by students coming from different locations.
Thanks, Leanne. Yeah, so first of all, South Africa has 11 official languages. 11 official languages, and now sign language has been added as a 12th official language. But we'll look at the 11. And for the majority of speakers in South Africa, English is a second or a third language. So the majority of our students, both at UWC and at Rhodes University, the English is a second or third language. At Rhodes University, most of our students are from Eastern Cape, so they will be isiXhosa speaking. But there are lots from, as I said, for both universities, from KwaZulu-Natal, and they'll be Zulu speaking. And so universities are looking at doing some things about multilingualism, but studies have not shown real improvement, because of course your workbooks are in English, your textbooks are in English, so we're teaching in English. So we do encourage our tutors, if they can speak the language of the students in their TUT group, then they may break into the language to explain a concept, but then we encourage them to break straight back into English, because the students have to be able to think in English, conceptualize in English in the end, so they can write in English. So we are cognizant of language, and but you might sit with a tutorial group with 4 different students from 4 different areas of the country. And if the tutor is speaking in isiXhosa, the students from Limpopo won't understand. So it is a challenge, and yes, we're cognizant of it. And if I can call a tutor into my group to ask them just to explain it, to get the concept across. If the understanding is there, then they can continue in English again.
Yeah.
So that's the kind of thing we think of.
Yeah, that's incredible, because the cognitive load of translating into 1 or 2 or 3 languages before you can perhaps explain something and understand something is really quite something. And so for students to be able to do that, and then also then interpret complex terminologies, like, you know, science terminologies is sometimes frustratingly overcomplicated sometimes. And so to be able to do that, and that is an incredible skill to have. And I think that's something that some of the particularly UK-based students who, you know, everything is taught in their first language, don't necessarily aren't able to practice that skill quite so much. So it's really, really quite significant. And it highlights some of the things that we've used these smart worksheets is to highlight some areas where they are struggling. And maybe Emily can explain a little bit about, there was one particular question where we knew that they were all getting this wrong, and it's just something just stood out. So we can use the results from these things for us to dive into understanding student behavior and learning behavior, because we can look at the number of auto solves and whether they're getting it right or wrong. Is that because we've written the question wrong? Is that because we've written the feedback not so great? Or is there something else going on, which is fascinating? So yeah, just to touch on that, Joyce, do you want to respond to that? And then Emily, perhaps you can just explain to people a few, particularly the one change that we made.
I think Emily can go ahead.
Yeah, okay.
Yeah, so yeah, after the results of the first iteration, which was amazing, and we've since put together an really comprehensive analytics system, which honestly this study that we did helped inform us about the sort of things that we would need in order to put together an analytics platform. So it all ties in together really nicely. But yeah, we looked at things such as questions where students were tripping up in particular amounts, and for each of those we looked at whether that was being taught in given contexts, whether the wording perhaps could be changed, or whether the question could be scaffolded a little bit more, or the question format changed so it was a bit lower stakes, which meant that we could get a sense of whether more of a sort of smooth gradient in terms of sort of how the mark distribution worked. And that's why some of the scores were a bit higher from the second year round, especially in like the graph component, which is where we looked at. Still lower than other sections, so it still needs work and is still an area that we struggle with. But it was really interesting to see how it was, yeah, in 2 different institutions, it was across the board. And in the survey, we did actually have a question which was asking, again, I won't go into detail because unpublished, but oh, I just muted myself for some reason. That was weird. I didn't touch anything. There was a survey question where we asked students how much they considered that they understood of the English and the technical language in the sheet. And then we can relate that to other responses, such as how helpful they found the sheet, the confidence that they had in their course before starting the sheet and afterwards, how helpful they found it. And I'm looking forward to digging into that data a bit more in the future. Yeah, so there's lots of interconnected systems going on here.
Thanks, Emily. Bill, you're muted now.
Hi, any further questions? I'll kick off with one from me first. Joyce, I was interested to see that the sheets are sort of performing a dual role. They're not just a diagnostic tool for you to inform your teaching, but from the student written feedback, they're clearly getting a lot from it themselves. It's really authentic practice for them at the same time. So I think that's quite hard to achieve sometimes. But in terms of what you're doing with the data, we've heard that what can be done, you can modify the assessments and provide more scaffolding, you know, support the students a bit further. But from your perspective, with the students who are coming through, what can you do with this data? What can you and your colleagues do with the data to support your teaching?
So first of all, making my colleagues aware of the weaknesses and the gaps, and that they're aware of it, so that when they get into certain things that they can, you know, be aware of it. And then we've for years had a kinetics practical where they've got to draw graphs, you know, log versus concentration and time and such things like that. And this year and last year, I have specified that I am taking total control of that practical, because I am going to work with every single, so for 5 afternoons a week, for 3 hours every afternoon, I will be walking around and working with the students as well as the demonstrators in the practical to get them to understand why your axis is the way you are, why when you're drawing to find the slope, you don't take your maximum point and the minimum point that you plotted, but you find the best straight line first, and that is the slope that you must use. It's little things like that that they insist on taking the first point and the last point and connecting them, and they use those points to form delta y over delta x. It's those little things to get them involved, and I am taking full responsibility to run with that now, just on this small little thing. As far as scientific units go, when I'm teaching units now, I do it as proportions. I don't do dimensional analysis. I show them how the dimensional analysis works, but you can, when you're converting from milliliters to liters, use proportions rather than just remembering whether you must divide by 1,000 or multiply by 1,000. My students can't, they don't. I had this yesterday. They can't decide whether you must multiply or divide by 1,000. They don't do the understanding whether you're going from a large or a small unit. And I think that's the problem, is actually understanding the size of the unit. So I'm not doing it with dimensional analysis. I'm trying scientific units using ratio and proportion as well.
Great. I think in your answer, what was so interesting there is that the outcome of this digital intervention is actually changing your face-to-face intervention in these kinetics practicals that you're running. Yep. That you go in there and get face-to-face with them and talk through it, you know, in person with them. And I think, you know, that is so critical that we consider digital solutions as part of that sort of blended approach. So we have another question here from John.
Hi, Joyce. Thank you. Yeah, this area has sort of fascinated me for years, from back when I was teaching in the laboratory as well. And something about you said very early on was that students not having a feel for numbers, and it just reminded me of that a skill which we don't typically teach, which is linked to what you actually just said about this. Should it be a bigger number or a smaller number when you change the unit? And that idea of being able to estimate a number. Okay, is this a sensible number? You know,
yes.
This answer that you've given me, does this make sense? And I think that is another area which would be really interesting to sort of explore in terms of students, not just their confidence, but getting maybe some sort of measure on that feel for numbers.
Absolutely, and feel for measurement. And I think that's probably, so I'll give you 2 examples. I run a maths and science club for grade 8s and 9s on Saturday mornings, and we do a measurement task, trying to assist them there already to try and bring it through, to make measurement real to them. And it's a rote learning process that the schools go through. So the children can tell us in the measurement workshop that there are 10 millimeters in a centimeter. And then we say to them, okay, draw a line. And they've got their rulers lying in front of them. Draw a line the length of a centimeter. And they draw it actually quite nicely, approximately close to a centimeter. Then we say, okay, draw a line the length of 1 millimeter. And invariably, 70% of these grade 8 learners make the millimeter line longer than the centimeter line. And then you say to them, how many millimeters in a centimeter? They say there are 10. How many? And you ask them again, how many millimeters in a centimeter? 10. So you say, do you really think that there are 10 of these are going to fit into there? And they just stare at you blankly. I had the same in my first year class. So I'm doing a remedial course now for first years, 400 meters. And my first year student now, yesterday, was quite happy to tell me there are 4 centimeters in 400 meters. And then I said to her, how long is 400 meters? She could not tell me. I then had to say to her, from this building up to across the street on the other side. And she couldn't believe that that was what 400 meters was. She could tell me how long 4 centimeters was.
It's fascinating, isn't it?
Yeah.
Because and then when we're asking them to conceptualize something like a number of moles, which is completely beyond their daily, comprehension.
Yep.
There's such a gap between those things for them to be able to understand. Yeah.
And then you talk about 10 to the power 23. It doesn't matter whether you have 10 to the plus 23 or 10 to the minus 23.
Yeah. Interesting. Thank you, Joyce.
Anybody else? Thomas.
Can you hear me?
Yeah.
Oh, laptop's been doing laptop things. This is in part a wee bit of kind of a feed off from your sort of saying about the analytics development and sort of seeing kind of where students were having difficulties coming in. I'd be curious to know, as much as it's thankfully not my issue trying to embed this, if along with the auto solve option, there was some way for the students to view an unrelated worked example. So say a default set of numbers that's not related to what's in their sheet, but whether that in any way impacts their ability or need to engage with that particularly technical terminology in that moment, or whether kind of it helps kind of cross that gap, if that makes any sense whatsoever.
Yeah, Emily, will you take over, please?
Yeah, I think so. I think you're discussing like worked examples for like a set value that isn't in the sheet. Is that right?
Pretty much. So essentially, it would then kind of almost be sort of 3 options. One is obviously answer it myself, and in my way probably get it wrong. But answer it myself. There's the auto solve, which is just kind of give me the answer. Hopefully, I can kind of work back from it. But there's that middle ground of almost give me a hint, but like what's the method that I then need to apply to the numbers in my sheet as kind of that middle ground as to whether I'd be curious to know how many would then engage with that option to then complete it themselves and move on as a way to actually get the answer themselves, just with that wee bit of quote unquote personal tutor help.
Yeah, that's a really nice idea. We have something similar for the quantitative skills smart worksheets, which we have for a range of topics, and that is at the start of each section we'll have a range of introductory information with set worked examples, and the feedback then will often refer them to that worked example. But that's mostly something that we've done for those sheets. So the scientific numeracy sheet described here doesn't have that, but it could definitely be something we consider, because sometimes it can definitely help to see, oh, okay, yeah, and I think worked examples, they are a very pedagogically sound concept. So yeah, definitely something we can think about integrating more.
Cool.
Yeah, thank you.
Yeah, that's great. I'm really, really passionate about formative work, formative assessment, and helping students to figure things out, getting it wrong to get it right, and things like that. And so I guess the difference between like a diagnostic sheet where you're trying to find those gaps sometimes having less of that learning, assessment for learning is kind of useful, because then you know really where those gaps are. But then to have maybe to switch to a way that you can then have it all really formative. So there's loads of very rich kind of clarification feedback. So if they've done a particular error, which we have already, done a particular error, you could say, remember, you've got to divide by 1,000 for this one. Try it again. But also then to maybe we could introduce something that you have just said, where we show them an actual proper worked example, perhaps, if they really still don't understand it after a couple of attempts, that perhaps we can look at it and give them a little bit more of a worked example. And then you're right, that would be really interesting to see how students behave with that, whether they just go straight to an auto solve because they, I don't know, I can't understand it, I'm not going to try and work it out again, go straight to an auto solve, or whether they engage with that particular, a slightly aside worked example. So that's that's really interesting. That would help us understand a bit more about their behavior and how fatigued they get with trying to work out certain challenges.
Yeah, because
thank you.
It relates a wee bit to one of the other things, because I really like I'm going to call it 2-tiered feedback that the sheets give, which is, I'm going to class it as you were wrong, try again, or you were close. So if you're like a rounding error off, or if you're a magnitude off, that those are built in. But again, obviously not having a list of all feedback ever. If there's somewhere, like if it's not already done within those, it might be somewhere to put those, not colloquial bits of advice, but sort of the you magnified, multiplied by 1,000, not divided.
Yeah.
We would expect this number to get smaller.
Yeah.
As that kind of, if it's not already in there, but that extra little bit of, sort of as Joyce was saying, that not philosophical, but like conceptual estimation of like, we expect the number to get smaller, you've made it bigger. That's where you went wrong.
Yeah, that's really interesting. So us to think about more about how we frame the feedback. So we can have it more factual, or we can have it slightly more conceptual, like you've said. So yeah, we'll definitely take that and think about that.
Cool.
Thank you. Joyce, I just had one quick question really about the educational research process. The numbers of respondents that you got was pretty phenomenal. You must have been thrilled. And then to take the design and then try to replicate it in a completely different university hundreds of miles away and then get big numbers there. What's your secret? How did you manage? Or maybe another way of saying that is, were you quite intentional about recruiting students, or did you leave it to them and you've just got really motivated students who want to help?
We were quite intentional. Because I was teaching them, when I introduced as I said, first of all, it was obligatory for them all to do it for marks. But the consent forms, we gave them hard copy consent forms in the lecture. And I think that's the difference. When you go electronic and ask them to, but the qualitative survey was on our learning management system. They didn't have a hard copy consent form. And especially when the consent forms were given out, specifically because I was teaching them and it was my research topic, I got another lecturer in to explain the study and for ethical reasons, explain the study and give out the consent forms. And yet it worked. And maybe we just have students who are prepared to do this. I don't know, but we're just very lucky. And as UWC got the most amazing situation as well. Yeah, I can't explain it, just grateful.
Yeah, interesting. And again, interesting that combination of digital and paper-based. We've got to be thinking very creatively about the best ways to do these kinds of bits of research. But I just want to say, I think that we'll round things off, but a huge thank you, Joyce, for sharing your results, and congratulations on having this published. On top of all of the work that you do, as we know, all academics are so busy these days, but it sounds like you're also helping in schools outreach significantly, giving up your Saturday mornings, and you're also able to dedicate, I'm sure, some of your own personal time to then, advancing educational research in this area. So I'm so glad that we are able to recognize that, and the judges awarded you, one of our awards. It's so well deserved. So thank you to everyone for coming. But just a final sort of thank you to Joyce for your presentation.
Thanks, Bill. But it wouldn't have been done without the Learn Size, without Emily and Leanne and the team's help in the background with all the work they've done as well. It was definitely a team effort altogether, and I want to thank them all for it.
Fantastic. Okay, well, thanks to everyone for attending this presentation.